If you were to take the Earth and shrink it down to the size of a single grain of sand, also shrinking everything else in the solar system proportionately, the Sun would end up being slightly larger than a golf ball. Along those same lines, if you took the Sun and shrunk it down until it was the same size as a grain of sand, the Milky Way galaxy would fill up almost the entire space between the Earth and the Moon. If you were to take this one step further and shrink the Milky Way galaxy down to the size of a grain of sand, the observable universe would span not one, but 5 football fields stacked side to side. In this video, I'm going to try to give a visual perspective to answer the question of how small are we? I'm going to be using a program called Celestia, which is a free downloadable program you can get online. We're going to start at the Earth and slowly start to zoom our way out, passing all the stars in the night sky, which make up just a tiny blob in the Milky Way galaxy. From there, we're going to zoom out even further until we're at the edge of the observable universe. I am Space by Jace, and welcome to my channel. Okay, so here's the Earth. You can see the International Space Station and Hubble orbiting around it. And as we start to zoom out, we're going to get to our nearest celestial neighbor, which is, of course, the Moon. The Moon is just shy of 240,000 miles away from the Earth. As of April 6, 2026, the Artemis II crew has traveled farther from Earth than any human ever has, reaching a distance of just over 250,000 miles away from Earth. They passed the far side of the Moon, breaking the Apollo 13 record, which was just shy of 250,000 miles. In the entirety of human existence, the Moon is the farthest humans have physically traveled. The next closest neighbor to us is Venus, but we're actually going to head the opposite direction and head towards Mars. Mars is 140 million miles from Earth and is the most likely first planet humans will visit. At an average of 444 million miles from Earth, we find my favorite planet, which is Jupiter. Jupiter is a failed star. If it were 14 times more massive, it would become a brown dwarf, but if it were 80 times more massive, it would actually become a red dwarf, which is a type of main sequence star. Even though Jupiter is not a star, it is still so massive that it acts as a safety net for Earth. Its powerful gravity catches objects that could have otherwise caused life-ending impacts on our home planet. This is the reason that Jupiter has 95 officially recognized moons. By speeding up time, you can get a really good idea of the swarming chaos around this planet. And if you think 95 moons is wild, which it is, just wait until you see Saturn. At an average distance of 750 to 930 million miles from us, we find a planet that has 274 officially recognized moons. Now, I don't know the names of all the moons, but I can tell you that Saturn is the least dense planet in our solar system. If you were to suspend Saturn in water, it would actually float. At this rate, it's going to take us forever to get to the end of the observable universe. So let's get cooking and head towards the largest thing in our solar system, the Sun. The Sun is a main sequence star, and it's basically a massive ball of nuclear fusion. You have hydrogen constantly fusing into helium, and this will go on for several billions of years. In another video, I go into more depth about the fusion process and also the life cycle of a main sequence star and what happens when they run out of fuel. The video that you're watching right now is all footage that I shot from my backyard using my Heliostar 76 telescope and Player One Apollo 428M Max camera. Each hour of real-time filming ends up being about 2 seconds of playback once fully processed. Our Sun is very average in size, and it is truly humbling how small we are compared to it. To get an idea of that scale, let's compare the Sun to everything else in our planetary system. The Sun makes up 99.86% of all mass in our solar system. Jupiter accounts for approximately 71% of the remaining 0.14%. Saturn accounts for approximately 20.4% of the remaining 0.14%. This means that all other planets, including the Earth, All other moons, comets, asteroid belts, etc. all add up to only 0.01 of a single percent of the mass remaining in our solar system. This is the approximate scale of everything we've talked about so far. Now we are going to start at the sun and zoom out until we are at the edge of the observable universe. As we zoom out, pay attention to the rate of travel away from the sun at the bottom of the screen. I meticulously calculated this so that it gives you an accurate representation of how fast we are traveling. It's going to continue to increase in speed as we get further away from the sun. As of right now, we are already traveling 60 times faster than the speed of light. You'll notice Earth on the bottom left-hand side of the screen. The distance between the sun and the Earth is called an astronomical unit. It takes light approximately 8 minutes and 20 seconds to travel that distance. As of right now, we are traveling half an astronomical unit per second. We are now traveling the distance between the sun and the Earth every second. One AU per second is roughly 500 times faster than the speed of light. On the far right, you'll see Neptune, which is the farthest planet from our sun, unless you still count Pluto. I want to pause at this distance for just a second. As of March 2026, Voyager 1 is now 172 AUs from the sun. It is traveling at 38,000 miles per hour and is roughly 16 billion miles from us. As we get farther from the sun, I have to switch to light years per second because of how fast we are traveling. Luckily, these next two objects are nowhere near us, but I want to pause here so I can show you the scale of them. This is TON 618, an ultramassive black hole. And this bad boy is Phoenix A, the largest black hole ever discovered. Remember when we shrunk the Earth down to the size of a single grain of sand? Well, once we actually got it down to the size of a marble, it would become a black hole. Considering that same density, the amount of mass that contributed to the formation of Phoenix A is truly beyond comprehension. Its diameter is the equivalent of traveling from the Earth to the Sun and back again 1,967 times. It's also the same as 130 Neptune orbits stacked side to side. And yes, the image is to scale. I counted every single orbit. We're going to skip ahead about 1 light year and things start to look interesting. Pay special attention to the constellations. At 4.24 light years from the Sun, we find our first stellar neighbor, Proxima Centauri. It's the little red dwarf that's orbiting the other two stars in this tri-star system called Alpha Centauri. It has only 12% of the mass that our sun has. As of right now, we are traveling 1 light year per second. When you look at the constellations in the night sky, our brains just assume that all of those stars are the same distance from us. As we zoom out, you'll realize that some of those stars are much farther away than others. The constellations themselves become unrecognizable and only familiar from our specific point of view. Our sun very quickly becomes lost in a vast sea of stars. As of right now, we are roughly 200 light years from the sun and traveling at 25 light years every second. Are you having an existential crisis yet? Because we're just getting started. I want you to remember this scale the next time something in your life feels too heavy. We are now 650 light years from the sun, and at this distance we find our closest nebula, NGC 7293, the Helix Nebula. Helix is a planetary nebula created by the ionized gas shell ejected from a dying star. It is roughly 3 light years in width. NASA's Parker Solar Probe is the fastest man-made object and can reach speeds up to 430,000 miles per hour. At that velocity, it would take the probe 2.8 million years to reach this distance. I now have to list our rate of travel as kiloparsecs per second. It takes light roughly 3.26 years to travel 1 parsec, and a kiloparsec is 1,000 of those. We are now just shy of 38,000 light years from the sun. Every single star you see in the night sky makes up a very tiny portion on a single arm of the Milky Way galaxy. It is estimated that the Milky Way is home to between 100 and 400 billion stars. Now it's time to leave our galaxy and see what else is out there. Our rate of travel is now megaparsecs per second. A megaparsec is 1 million parsecs. The observable universe has a diameter of 28,500 megaparsecs. In this image, each dot represents a documented galaxy. You'll notice how galaxies start to shift red the further they are from us. Let's talk about what redshift is. To understand redshift, we need to talk about the electromagnetic spectrum. As the name implies, waves on the electromagnetic spectrum are controlled by oscillating electric and magnetic forces. A wavelength is a measure of distance between two consecutive peaks of a wave. Frequency is determined by how many peaks occur in a certain amount of time. Waves with more energy, such as gamma, have a higher frequency, and waves with less energy have a lower frequency. Galaxies traveling towards us display blue shift as their light waves are compressed. This is a visual example of the Doppler effect. Galaxies traveling away from us display redshift. As the universe expands, space itself stretches, causing light traveling through it to experience a cosmological redshift. The universe is expanding at a rate of 67 to 74 kilometers per second per megaparsec. The farther away a galaxy is, the faster it is traveling away from us. This relationship between distance and redshift is known as the Hubble-Lemaitre law. The expansion stretches light waves beyond the visible spectrum, eventually to the point where modern instruments can no longer detect them. This is the edge of the observable universe. As of April 2026, the Dark Energy Spectroscopic Instrument, or DESI, completed the largest high-resolution 3D map of the universe. It utilizes 5,000 robotically controlled positioners, each with its own optical fiber to capture light from galaxies. DESI aims to survey quasars and galaxies in a third of the night sky within its 5-year mission. It can detect objects up to 11 billion light-years away. In this ongoing map released by DESI Collaboration and Berkeley Lab, every single dot you see represents either a documented galaxy or quasar. It has successfully mapped more than 47 million galaxies and quasars. The observable universe is estimated to contain roughly 2 trillion galaxies. There is physically no way for us to know how many are beyond what we can detect. In the universe, even the Milky Way galaxy is as insignificant as a single grain of sand is on Earth. But speaking of Earth, I better get you all back home. Thank you guys so much for watching this video. I had a ton of fun making it. If you like what you saw, I invite you to subscribe for more nerdy space content. We'll see ya.